Just to let you all know, I'm here with Dr. Susan Ellis-Felege, but we'll do some of the intro stuff first. So you can contact us via our Twitter handles if you have questions afterwards. And if you want to be able to see this later, go check out wildlifebiogal.com, where there's the links for YouTube and SoundCloud, so you can check those out later after I get them loaded up. It'll probably be after the conference, just because of how busy it is here. There's no way I'm going to want to do it tonight. So I'm sitting here live at TGOS 2016 in Raleigh, North Carolina with Dr. Susan Ellis-Felege from the University of North Dakota. And why don't you tell us a little bit about your background with, where you did your grad school and undergrad and getting to North Dakota.
Grew up in Western Pennsylvania, and I did my undergrad at Penn State Barron, which is the second largest Penn State campus, where I did a lot of undergraduate research looking at house wren incubation patterns, and got to get my first experiences with conferences and maybe my own science communication practices there. And while I did that, I also worked with the Pennsylvania Game Commission, doing a lot of work with them with waterfowl species. So I then went on and started a master's at the University of Georgia in Athens. And after the first year of that project, I turned it into a PhD and rolled straight through, working on nest predation of northern bobwhite quail. So did that with nest cameras. So lots of footage looking at who eats quail and what does that mean with respect to predator control or predator removal. And now I'm at the University of North Dakota. I actually taught for a year after I finished my PhD at Georgia, and then landed the big kid job at the University of North Dakota as an assistant professor, where I've been this is the start of my 6th year, so 5 full years.
So with talking about nest cams, can you tell us, first of all, what is a nest cam for the people out there who might not know what that is?
So I put miniature surveillance cameras, much like you'd find in a gas station in the corner, the security type cameras, right by bird nests. And I've done this with now, I think it's 8 species and 3 different families of birds, ranging from waterfowl to shorebirds, to some game birds, or some upland game birds. So yep, it's just a little camera. I don't use any Wi-Fi. I just use ones that record to a little DVR, and then I amount to 20 to 30,000 hours of video per species, and in some cases much more than that.
So why use a nest cam? Why not just have a tech sitting out there? Like, what differences are you seeing with things?
Well, because I usually can't hire 30 techs.
Okay.
So sample size is a big thing. I can put cameras out. They can watch 24 hours a day, 7 days a week, as long as all the technology cooperates. And it should have less of an impact on the wildlife than having a person sitting there, which might alter who the predator is or even how the bird might behave. So allows us a better way to understand bird behaviors and interactions with other species on the landscape.
What are some of the different bird behaviors that you're seeing on those cameras?
Oh, we get all kinds of things. Some of them are not very exciting. Sometimes it's just a bird sitting there, much like you'd see with, say, a sharp-tailed grouse or a duck that just sits there and maybe occasionally preens or rolls eggs. But some of the more exciting things, we see birds that will engage in nest defense or do some kind of distraction displays to try to take predators away from the nest. We see some of them actively fight off predators. I have a good example of that where there's a bobwhite actually pouncing on an armadillo. And then there's other predator behaviors you see, or strange predators, like white-tailed deer eating eggs, which people don't tend to expect. Or up north we see sandhill cranes pulling eggs out from underneath common eiders.
Okay. So with those different behaviors, how do you quantify what it is that they're doing? That there's differences in different areas. Are you looking at impacts of humans into those different nesting areas, and that's what you're using the nest cams for, to measure those behaviors?
Depends. There's a lot of different questions. Original question that I started off with was understanding behaviors relative to predator reduction. So removing mesomammalian predators, so that was for the quail project, and understanding some of the interactions with those predators. And so that was that question. Others have been relative to, say, sharp-tailed grouse and the nesting ecology relative to gas and oil development. How do they behave? Do they behave any differently in areas of intense gas and oil versus not intense? and what does that mean, and are there any predator differences there? Other questions might be in the places where birds are stressed and things are changing, like a dynamic landscape like you might see up north along the Hudson Bay with some of the eiders and snow geese, where climate change might be ultimately resulting in different pressures each year on the birds with the variable weather patterns we see.
How often are you having to go out and collect data from the cams or changing batteries? Yeah.
So our cameras we set up can run for about 4 to 5 days when they're brand new on a 12 volt 35 amp battery. So a little bit heavy, a little bit bigger than sort of a tractor battery that powers them, and then they record onto a 32 gigabyte SD card. So we go out and change the SD card about every 4 to 5 days. When we get older systems and batteries start to be a little fluky, sometimes we got to get out there every 3 days.
Okay. And I may have missed this, but does this run continuously? So is it constantly getting video, or is it just when the animal is doing any sort of movement that you're collecting?
It's constant.
Okay.
We collect everything. We don't want to miss things, and oftentimes motion triggers aren't always sensitive to things like smaller predators that might come into the area. So we do 24/7, which amounts to hundreds of thousands of hours of video.
Wow. So what kind of data quality is it? Like, I mean, if you only have a 32 gigabyte SD card and you're running it constantly, like what kind of like video resolution are you getting on this?
It's pretty low quality.
Okay.
It's not high definition by any means. It depends on the system and how much grass and things are in it. I think it's 352 by, I forget the other dimension.
Okay.
For the ones that are in grasslands, because the grass moves and it eats up the video space faster.
Mm-hmm.
We work with our shorebirds, which are out in the wide open. We actually can do, I think it's 740 or something like that.
Okay.
So it's a little bit bigger, a little bit higher quality, but it's still very limited. It's not the high definition you'd find, because otherwise you'd just not have the space to store it. I mean, I now have hundreds of thousands of hours of video and almost take up about a third of the storage that the university has just with my videos alone. So it can't be any higher quality.
How do you go about processing all of those videos? Is it just you and your students that are running it, or do you have to like seek outside help for being able to process all those videos?
All of the above, in that we have students, so I have a small army of students who all get experience, and we do it through directed studies. They're technicians, sometimes they get paid, and they video watch a substantial amount of it. We also have what's called Wildlife at Home. It's a citizen science project where you can go in and help us classify the video and watch it. And so if you Google Wildlife at Home at UND, it'll be the first thing that usually comes up on the Google hit, and you can go in, you classify the behaviors, and then we compare those and see how they look with what we as scientists, our kind of project scientists, find. And then we also have a team of computer scientists working to do automated things, and we've actually gotten with some of the shorebirds where it's wide open and not a lot of conflict with cryptic coloration and a lot of veg. You can not just tell when the bird is on and off the nest, but we're starting to get where we can classify even what behaviors we're seeing.
Okay. So if you want to go out into that, citizen science project that you have, do you have to be an expert in birds to be able to do that, or can you just be like, hey, I like watching birds and this sounds interesting?
Just have to have an interest and a passion to sit there and watch it and help us classify. There's a lot of instructions there, and you can always email us and ask us additional questions. There's discussion boards you can post to and let us know what questions you have.
So you've started to get a little bit more interested in science communication, and I noticed you have this Fieldwork Friday thing. What can you tell us about that?
Well, I think that as scientists we have to do a better job of communicating, and I personally probably don't do the best at that, and especially communicating with the general public, get them excited about conservation. And so one of the things that I've started doing is we've collected hundreds of thousands of hours of video, and we have some real blockbusters, for lack of a better way of describing them, as well as trail camera pictures and images. So each Friday we post a event that we found from our previous field season or current one, depending on the time of the year, and you can see what we're doing in our lab and hopefully get excited about everything from polar bears to wolves to the birds that oftentimes get eaten by these critters.
Wow. So speaking of polar bear work, so you don't just do nest cams, you also are up in Canada, I believe, doing work up there?
Yep, so I have nest cam stuff all through North Dakota, and then I've started work with the Hudson Bay project, working on the western Hudson Bay and in the area where there's a lot of snow geese that nest there. And so we're monitoring snow geese. We're using actually little miniature surveillance cameras, these Nest cams, to look at how birds respond to drones and how we fly these unmanned aircraft or drones in a systematic sort of survey protocol way. So we use it actually to answer questions surrounding our monitoring methods, as well as eiders that are kind of a cool sea ducker.
So you're basically doing all this remote sensing type of research. What is the benefits of remote sensing versus, I don't know, maybe the traditional, biology?
So the traditional field biologist carries out there and goes and sees that, they've got their binoculars and they're out there watching, but the perk to this is putting all these different ways out on the landscape. One, we get archival data, something that ultimately can be utilized for other purposes, including education, as well as secondary purposes, sort of repurposing. So I might be interested in predator ecology and who's eating a nest, but I can ultimately look back at incubation rhythms. So how does a bird spend its time? So it gives me an advantage to archive all this data, have multiple people look at it, get multiple points of view about what's happening with different people with different expertise, and it takes the human out of the equation. A person sitting there can influence how species interact.
Is it safer for the scientists to use the ways of remote sensing that you're doing? We hear about helicopter crashes with people trying to do surveys with doing the unmanned systems. Is that a safer way for the scientists?
We would hope.
Okay.
So probably the number one source of mortality related to work and field work and things like that for wildlife biologists is low altitude, slow flights. And that's in helicopters, that's in planes. And so, yeah, using an unmanned aircraft provides an alternative, safer way. We hope it's less invasive. That's something that still needs to be more rigorously tested, and especially the protocols that people use. And we also hope that it'll allow us to collect a wide variety of data, perhaps in a more cost-effective way.
For those of you who are tuning in, we're live from TWS 2016 with Dr. Susan Ellis-Felege talking about her work at the University of North Dakota with remote sensing via Nest cams, and then also UAS, or unmanned aerial systems, looking at snow geese and polar bears now. Are there any other animals that you might want to translate this to in the future, like other species that you might be interested in, that you think this kind of work might go well with?
Well, I think that the options and the possibilities are probably limitless. We're hoping to think about it too in the plant species interaction, so understanding habitat characteristics associated with why wildlife are in certain places and habitat selection type questions, as well as densities. And then with snow geese, it's how much destruction. So they're overabundant snow geese that come through an area and they eat all the vegetation, particularly the grassy type things, graminoids. And so we want to be able to understand how the landscape's changing in response to the presence of those birds. But the possibilities are endless. It just takes responsible use, which is what I'd like to see, and people not flying something like a UAS just because it's the cool, sexy toy.
Right.
It needs to be flown with purpose, and it needs to be flown with a very good science question to start out with. Start with the science question, and then ask yourself, is that actually the right tool? Is there a better way? And in many cases, there are still better ways, just because there's still a lot of limitations to this technology. Logistically, it's a challenging thing with some of the permitting and the changing horizon regulatory-wise. But it's also something, technology is going so rapidly with it, and having the right sensors to fit the job, that some of those are in development, some of them are cost prohibitive.
Do you think with having that imagery that you're getting from the cameras, both on land and up in the air, do you find that you're having a better historical catalog, that way people can trust your data that you're collecting more because you actually have that image, versus someone's like, hey, I saw this goose flying by, well, how do we know that it really was that particular species of goose? You have to trust that scientist, but here you have that. Do you find that that's helping out with people believing the data that you have?
I guess I haven't noticed anything with that, but that's
Okay.
a good point. And yeah, I mean, it gives you a chance for multiple people to look at it and validate it, see what it is. And now with all these open source records that are required when things are federally funded, what does that data really look like? In some cases, some of the different things, you could have video and image backups that sort of go with those spreadsheets that you're creating, or the actual data you analyze. So.
And also another thing too, with engaging the public, do you find with having that imagery in those videos that you're better able to engage the public and get them to understand the situations of the species that you're working with?
Absolutely. Nothing, I mean, a picture's worth 1,000 words, they say, and absolutely, there's nothing that grabs someone's attention more than a really good little video clip or an image that tells the story that you're trying to say, and can communicate it far better than I can in words.
Right. Yeah, interpretive dance only goes so far.
Yep, yeah, definitely.
So, all right, well, everyone, if you've got any last-second questions here, send them in. Otherwise, I'm going to let Susan head back into the conference, and I'm going to go back in as well because it's the last day here. So there's a few last talks we might want to go check out, or we might just want to go take a nap and crash after the long conference because Wildlife Society, it's an exhausting process being here, but we love it. So since I don't see any other questions, I'll do a quick sign off and just remind everyone, feel free to get a hold of us via our Twitter handles at Wildlife BioGal and Felege Lab. And then if you want to be able to watch the video later or the podcast or listen to the podcast afterwards, go to wildlifebiogal.com and there'll be the links for that, and I will get those loaded up later on. And I encourage you to go check out, what was the website again for that citizen
Wildlife
science
at Home?
Yeah, Wildlife at Home. So go and help Susan identify bird behaviors and become a citizen science. So it'd be a great way for you to get back to nature and to science and feel like you're doing some good hard research work with all of us. So with that, we'll sign off for Raleigh and have a great afternoon.
Thank you.